What's up, everybody? Welcome back to Undefined Engineering. It's Christian. I'm here with my brother Patrick, joining me from Colorado. We got a big one for y'all today. Main topic of this podcast is going to be thinking like an engineer. So what that entails is essentially successful engineering thought processes and methodologies that we use to be a successful engineer in the career field that we're in. And that would be covering topics like the goal of an overall engineer, first principles thinking and questioning your constraints, the black box approach to problem solving, and in general thinking as a system. And moving on from there, we'll get into the differences between senior and junior engineering approaches, and get into some examples along the way as well in this podcast. And we'll also go over challenges for beginner engineers and how you can progress in your career field rapidly. That being said, Patrick, how are you doing?
Doing good. Excited about the topics and diving in and learning more about all of them and stuff. But the viewer,
Nice,
I'm learning,
me too.
Learning just as much as the viewer is.
Yeah, no, that's this will be a fun one. It'll be an informative one. It'll probably hurt my brain a little bit as we go through it. That's for sure. Before we get started, let's get into our current roles and kind of what gives us a little bit of credibility into what we're talking about. That way people don't think we're just making things up off the top of our head. Patrick, current role and experience.
So had a bunch of internship experiences throughout college in manufacturing with like GM, E-Controls, Standard Aero, aerospace, and automotive. Most recently, I was a design engineer within trust, within utilities and things like that. And just now transitioning to a new role as a product engineer, working with compressors and things like that.
Nice. Yeah, that's awesome. I'm currently a senior quality engineer for an autonomous drone manufacturer, covering all low voltage systems in the aircraft. Before that, I was a quality engineer at Tesla, where I worked on both the Model Y and Cybertruck, covering firmware and low voltage systems for each one of those areas. And before that, I was a quality engineer at Toyota, where I was supporting the Sequoia and the Tundra. Before that, I'm not going to get into internship experiences, had a few before then. But yeah, that's kind of what got me here and talking to everybody here today. Sweet. That being said, you want to dive right into it?
Yeah, let's do it.
Cool. So the first topic I wanted to talk about is something that kind of Elon made pretty famous for engineers tuning into what Tesla was doing, what SpaceX was doing in the engineering world, and that's first principles engineering. Patrick, do you have any experience with what first principles engineering is? You've never heard of it? Okay, cool. Yeah, so it kind of opened up how I approach problems and approached designs as an engineer. Pretty much as soon as I heard about it coming out of, I think I heard of it when I was in college. But essentially what first principles engineering is, it's a crucial mindset for problem solving and innovation in engineering. And what it does, it essentially forces the engineer to break down the complex problems into their most fundamental components and really understand the core principles and truths that govern the problem.
I'm stupid. I definitely seen that in classes. I just haven't heard the term in a long time.
Oh, you've seen that in classes?
Yeah.
Oh, wow. They didn't cover first principles engineering when I was in college, but I'm glad to see that that's making its way into the academia.
Something else. Maybe that's why. But I've definitely seen the breaking down problems into
I'm sure
simple parts and things like that.
It's touched upon when you study lean manufacturing. So if you've taken a lean manufacturing class, I'm sure you've gotten into it. Yeah, it's a big fundamental of design and manufacturing. Anyways, moving forward, why first principles engineering matters, right? So essentially, the big thing about first principles engineering is it enables you to drive innovative solutions by avoiding conventional constraints. So another big thing that Elon preached in his companies was always question your constraints. Don't be siloed into a certain set of thinking just because it's always been done in the past. Always innovate and always try to do the impossible and find those creative solutions to essentially drive success forward in your company. Essentially, when you're talking about first principles engineering, there's four main things that are really you really want to essentially drive home as you're going through it. And that's identifying your problem. So clearly defining what you're what you're trying to solve and breaking it down into manageable components. Deconstructing your problem. So analyzing each component to understand its fundamental principles. Ask what are your underlying assumptions? Like, what are the core facts? What actually matters in this situation? Then reconstruct your solution, which is like rebuilding your solution from the ground up, just using fundamental principles that center around your problem, and experiment with like new approaches and technologies as you're going through it. And then the last step is just testing and iterating. So like implementing your solution and testing its effectiveness and doing this as fast as possible. And I think this is something that was tough for me when I got into the engineering world to like get used to, especially going from Toyota to Tesla. Toyota was a much more structured problem solving approach where it was like essentially the 8Ds approach to problem solving that like Ford created, that or Toyota built upon, which is like identifying your problem, setting your target, like understanding where the problem's occurring, setting or identifying root causes and like method of the problem happening, setting countermeasures, seeing your countermeasures through, and then like identifying the results. Essentially, it's like big picture of what the 8D was. Yeah. Any questions on like first principles engineering and like how you like envision it happening in the career field, or like where you've seen it happen firsthand?
So just like in summary, it's just like get rid of like all like the unnecessary information and stuff, and accomplish tasks as fast as possible while also like still having innovative solutions and not just doing things by the book.
Exactly. Yeah. I really like first principles engineering because it sets you up with a problem solving strategy that is centered around like Elon's three main core values in being successful in one of his companies, which is essentially question your constraints, like make your requirements less dumb. Essentially, why am I blanking right now? Question your constraints, design out the part if possible, and optimize your processes. So I really like that like first principles engineering kind of gives you a game plan to like accomplish those like three main goals.
I do like the message it sends, because I think especially going to big companies, they have a lot of, how you said, like standardization on how things should be done and solved if things happen, because so much things have happened already throughout the company's lifespan. So it's easy just for like other engineers and people to tell you this is how it's always done. Just do it this way, instead
Yeah.
of coming up with like a solution that could improve the whole process.
Yeah, no, that's definitely a huge thing. That's something that people will struggle with going to a big company for sure. Is walking in and not being able to change anything, not being able to optimize anything, because you're walking into an environment that's so tightly controlled and so constrained that you're essentially having to go through like 8 levels of approval before you make something happen that's right in front of you. It's sometimes backwards, and it's what keeps companies like Boeing or Lockheed Martin from being able to compete with companies like SpaceX.
Yeah, I think people also entering the industry will be surprised of how like archaic some processes are in these companies.
Oh
And there
yeah.
will be opportunity to improve processes like early on.
Oh yeah, definitely. Dude, that was one of the biggest things that like hit me in the face when I started getting into the career field. Even at Toyota, like some of these things you learn in class, where it's like, oh, agile manufacturing, lean manufacturing, eliminating waste. You think like every company was already doing this, but then you go into a manufacturing environment or any sort of environment, and you're like, wow, none of the practices or methodologies that we learn in school are being utilized here. Like, why isn't that happening? It's pretty crazy.
Yeah, this isn't like manufacturing based, but my previous job as a design engineer, kind of going with the flow of always trying to find ways to change processes and things. Like for example, we had just a really just outdated system of how we shared drawings. We would just email it back and forth. By the time like drafting and the other engineers got it, there'd be like 50 different copies with red lines from 50 different people.
Oh,
And 2 weeks of being there, me and the other new hires figured out, oh, there was a cloud server built into the software we use to edit the drawings. So we could all just collaboratively work on the same document at the same time. And they were just amazed by that. And I was like, it's just amazing to me that no one could figure that out or even thought of that.
no,
So it's like,
exactly.
it's kind of like a thing of like, oh, there's an opportunity for me to change something and bring it up.
And you eliminated 50 steps of traceability.
Yeah.
That could essentially lead to like a major failure. That's good. That's awesome. So I know theoretically, like, you don't hear first principles engineering a lot, but like when you see a problem in real life, like what sort of mindset do you take towards like tackling that problem, Patrick?
I freak
Is there like
out.
a certain method? You freak out? You say, I
No,
just work here?
I think I try to think of it as simple as possible because I know like engineers, I feel like they tend to overthink things. So I just, while I'm looking at a problem and I'm thinking of like possible solutions or how I should approach it, I'm thinking of like try to keep those as simple as I possibly can because most of the time the problems don't need a mastermind to fix them.
Yeah, exactly. And I think that hits on the first principles engineering aspect. Like, make it as simple as possible. Don't overcomplicate things. It's so easy to start over constraining and over inflating your problem into something that just doesn't make sense. It's kind of like when you're in a meeting and you start the meeting with one subject and then you start rabbit holing and you start solving problems that have no relation to like what y'all started the meeting in the first place. It's kind of like that. It's easy to get down that rabbit hole and snowball into something that just essentially doesn't matter.
Yeah, super important to like understand your scope and not just rabbit hole out of it, like you said.
Yeah, but in terms of like actually solving a problem that's in front of you, do you have like any defined method that you try to stick to when you approach a problem? Like, do you have a standardized way of like looking at something, or is it free flowing and constantly changing?
Kind of more free flowing. I wouldn't say it's like I have a standardized way. I know there are probably standardized methodologies to go about solving a problem, but I just kind of free flow, go with the flow.
Go with the flow. Yeah, I mean, that I've definitely done that a lot of times in the past. Actually, I still do that all the time. But there is one method that I've kind of like stuck to and gelled with really well, and it's called the black box approach. So essentially what the black box approach is, it's a certain problem solving method of analyzing systems by like focusing solely on its inputs and outputs. So essentially, let's say like you're given a problem and you don't know like any of the interactions of the system with the problem, but you know what's going into the system and what's outputting the system. You don't necessarily need to know all the complex interactions of that system, as long as you can identify like what your key inputs are, what your key outputs are, and then you can essentially create like a design of experiments to solve that problem. That's essentially in a black box because you don't really know what's happening internal to the system itself. And I found that that's helped me out,
So is that
yeah, a lot.
like to alleviate? Because I know like during like previous experiences, I get overwhelmed sometimes because I feel like to solve a certain issue, you have to be like a super expert on whatever process you're looking at. So is that to like alleviate that?
Yeah, so
Like you don't have to know everything.
yeah, it's essentially a great start. Like, say you're a new engineer, you're a junior engineer, you're not a subject matter expert of like the thing you're working on. It's a way for you to start the problem solving process and contribute, starting from like a high level versus actually being in the weeds of like what's going on in that system. And it's something that I relied upon heavily when I first started. It's essentially like an internal structure, or work like it's a way for you to analyze the internal structure without considering like the things that are in that internal structure straight off the start, which is really nice. Um, and like leading into that, it's a way to like start thinking of things as an overall system versus like individual components, which is something that's going to benefit every engineer later on, especially like individual product designers. If you develop your product while thinking of it as a system, then it makes it a whole lot easier to integrate and scale moving forward in the future.
Is it like I don't know if you have one on top of your head or something, like an example of like a
A black box?
time you would use it or you used it?
Yeah, so I can go over an example that I used in my previous role. At Tesla. Let me try not to give any sort of confidential information away, but there was a situation, let's say with a car, no specific model, where a driver would do something, and essentially they'd get an alert on their screen. Let's completely made up example. They'd press the brake, right? Essentially, they'd press the brake, and an alert would pop up on their screen that they lose voltage somewhere in the system. In this situation, I know exactly what my inputs are. So let's say they have the car in drive. It doesn't happen when it's in reverse, or let's just say it happens when the car's in drive, reverse, and parked. They press the brake and they get an alert on the screen, right? So I know my output is getting an alert for low voltage somewhere in the system. So essentially, I don't know anything about the internal structure of this. I just know my inputs and outputs. So I base my experiment off of what my inputs and outputs are. So like, since I know these are my inputs, I'll look at essentially whatever system level drawing or whatever system level information I could find that's associated with these inputs, and then I would tie them to the output I'm seeing. So let's say like when they're pressing the brakes, okay, I trace that brake line through the car itself, and I find that when that brake line is pressed, a bunch of different lights go off in the car, right? So like you have your tail light, your upper tail light, you have your left and right tail lights. And I see that when I press that brake, those things are physically interacting. So I'll go to those three things and essentially say, okay, this is part of my output now too. So I'll do a design of experiments of like disconnecting each one of those outputs. If I disconnect each one of those outputs, do I still get the alert on the screen when I give my input? And let's say I go through three of them. I find that when I disconnect the right tail light, the information on the screen goes away. So like there's no indication for low voltage. All right, okay, so from that right tail light, how can I signal trace that in a way to see like how it interacts with my input from the brake? So then I put that all together and I see when I press my brake, it essentially activates a power line that runs next to the right tail light line. So I see that they're physically close to each other. So here, what I want to do is when I press the brake, I should probe that line and see if there's any sort of interaction happening when I press the brake. So I press the brake, I probe the line, and let's say I see voltage drop from 12 volts to 9 volts, and that's enough to trigger the alert, right? From there, I'm like, okay, why is this happening? So essentially, from there, I would switch to like an oscilloscope, and I'd monitor that signal on the line itself, and I see, oh, when I press the brake and the voltage drops, I see a lot of interference in that line. And essentially from there, I could be like, okay, since I'm seeing a lot of interference, there's probably a lot of EMI going through this line. And then I'll check to see what the source of the EMI is and see if I can isolate it to like a light that's pulling too much current or spec'd out wrong. So I'll swap the tail light, see if it works, right? Then I swap in the tail light and the system or the problem goes away. So then using like my black box technique, I've gone through my inputs, I've gone through my outputs, I've seen how they've interacted by doing a design of experiments comparing my inputs and outputs, and I was able to like localize the issue to a tail light, right?
So
from
what I got from that, it's basically saving your time by saying, hey, you don't need to become familiar with the whole system. Start with the inputs and outputs, and you can follow the trace as you go along.
Exactly.
So instead of wasting time with the whole system, just doing the inputs and outputs, you immediately focus on a smaller set of systems and just trace it.
Exactly. And I know if I was like a newer engineer hopping into that situation, I'd be like, well, I get an alert for voltage dropping here, but I have no idea like how the whole car works. Like, do I need to figure out how the car works from a high level perspective and start drilling down through every single like low voltage system on the car? No, you just need to essentially think about and worry about the things that are directly influencing like what's going on at a high level, which is something I appreciate. And
that would have been good to know, because I'm one of those that gets like overwhelmed. I'm like, I need to become an expert of this whole freaking thing to answer this, or to do this project or task.
And you'll find like that black box approach I mean, it's helped me even at work right now. I ran into a situation like 2 days ago where I was working with a couple of electronics design engineers, and we were dealing with an issue in prototyping. And essentially, um, since like the electronic design engineer saw a failure with one of our controllers, and since they're so invested in the design because they're the owner of that design, they've created the whole thing. They immediately like started diving into like very granular circuits and systems on the board to see like what's going on here. They started probing random places to see if they were getting voltage and voltage anywhere. And I was like, hey, look, let's take a step back. When we're considering this controller, let's draw a line around the controller itself and see what exactly is failing. What are our inputs to this area? I see that like a load switch needs to be initiated for this separate part of the system to get power. Well, what does a load switch need to initiate? Well, the controller itself has to be updated with the proper firmware. And it was like a situation where the controller itself just wasn't flashed to the correct firmware. But the design engineer like started deep diving and probing the system and getting really granular with it before they considered it from a high level.
I think that also brings up the importance of having like cold eye reviews or like someone outside not familiar with stuff giving their input just to keep the high level and try to keep it as simple as possible from their perspective and everything.
Yeah, exactly. That's a huge thing. Cold eye reviews, man. You'll never know how simple of a mistake you're making until someone that's unrelated to it at all comes in and is like, why are you doing it that way? that doesn't make sense. Yeah. Have you ever ran into that situation in your career yet? I know it's still pretty early for you, but like if you're ever dealing with a problem, are you like, man, let's take a step back?
Yeah. And just some of like the higher level engineers would be talking about stuff and they just like there'd be issues with the regulator systems or like why isn't this working? And it's like some of the issues would be like, oh, this pipe, you inputted the wrong diameter on this pipe, but they were considering like all like the temperature differences and all that stuff and all the thermal properties. I was like, oh, that pipe on that drawing you put 2 inches should be 3. That's why it's not doing it. In the simulation you put the wrong size. So like,
nice, it's as simple as that.
Yeah, just requires because I feel like when you're so ingrained into a project or system, like it's easy to just think it's the most catastrophic error that's happening. So you're like trying to really figure it out, but it could be something really simple.
That's another thing too. Like a big thing I found with design engineers is I don't want to call and say like every design engineer does this. I don't think every design engineer does this, but I mean, even myself, not being a design engineer, I've been guilty of this. Is only considering my product or commodity at a local level versus a system level. So like essentially, as an engineer, you'd want to consider, and I know a lot of people do this already, but you'd want to consider your design as a system versus as a local product. So you'd want to ensure like you have a comprehensive understanding of how different components interact and impact one another, even if those components aren't directly related with like what you're designing. So like a holistic approach like this essentially prevents sub-optimization, where improvements to like individual components might inadvertently create inefficiencies or conflict elsewhere, like in a system.
That's smart.
Yeah. I feel like essentially it just leads to a more cohesive and effective solution that addresses like from the root cause versus a design engineer like creating a solution that impacts somewhere else. And not only that, when you consider like the system as a whole, you'll be able to scale your product better. And that's something that a lot of people need to realize when they're designing for manufacturing, especially like a big manufacturing system.
No, I've definitely seen that. And just people not considering systems.
Yeah. Speaking of that, I feel like we could get into a engineering example and see how a junior engineer would approach a problem versus a senior engineer. I kind of am biased because I made this example, so I've had time to think about it a little bit. But Patrick, let's see how you would approach this problem. So let's get moving with an example. Go ahead and share my screen here. Alrighty. Can you see that?
Right. Yeah.
Cool, cool. All right. So let's say you're a design engineer for a company who produces modular go-karts. In this modular go-kart, you have a rear car, a mid car, and a front car module that's swappable and secured together by a metal interconnect bulkhead that is inserted before you mate the car modules. So essentially, you can see how we have this split into 3 sections, right? So let's say at this split area, there's a metal bulkhead that the rear module and the mid car module essentially mount to. So that's like what's holding the modules together, right? You own the entire design of the mid-car module. So you, Patrick, are the owner of the mid-car module design. So you are responsible for everything that's in that mid-car. And your company is currently in build prototyping. You experience a problem installing 3 controllers that are individually installed to the structure of the mid-car near where the rear car and mid-car connect. So that's the situation, right? Any questions on that?
Nope.
Cool. So the problem itself, you are unable to install 3 controllers to their mounting brackets that you designed due to 2 factors. There's hole misalignment between the controller and the bracket. So you can see here, I have a controller, generic controller that I pulled offline, and a bracket, generic bracket. These two aren't necessarily linked. I just wanted to show you a picture of like what essentially the possible scenario is. So these 3 holes are not aligning with these 3 holes. They're essentially winking. And let's say during your prototype process, your solution is you have to drill out both holes and get a larger fastener to make this fit. And not only this, you have difficulty seeing the inside of your structure when you're mounting this controller to this bracket. Now, this mounting bracket, per your design, comes installed on the structure from supplier. So how would you approach this problem?
I feel like the simplest way would to begin with the drawings and tolerances. So look at the drawings for the bracket of the controller casing. Verify the datums make sense. They're rigid datums and not fluid. So make sure the positions don't move around when you mess with different things. And then make sure, just make sure the positioning of the holes match up and the max tolerances doesn't take it outside the max range and things like that would be my first guess on how to first approach it.
Yeah. And I'm sure you'd like, not only that, I know you'd want to verify like the supplier is sending you conforming parts. So you'd confirm like the controller and the brackets are to like your specified design.
Yeah.
So yeah, let's say you did that and they are in tolerance per your design. You essentially said you'd move forward with like a tolerance stack up and see if any of those positional callouts or size callouts were conflicting in any way. Okay. And if that were the case, you'd move forward with like fixing the tolerance callouts for this, right?
Going through the whole process of changing the tolerances and the drawings and all the documentation that requires and things like that.
Nice. And for like the issue with difficulty seeing, you're assuming like once you have the tolerance defined and everything's in spec, it'll just become easier to install because everything's just fitting together. All right.
Hopefully.
Cool. Sweet. Yeah, that's interesting. So
now school me.
No, I'm not necessarily going to school you. I'm just going to come at it from a different approach because like there's many approaches you can take to solve this problem. But my approach, like when I look at this and touching on the topics that we talked about in this podcast so far, is like when you think about it from a first principles engineering approach, let's say like question your constraints. When you think of your like whole system, what exactly are you needing from this mid-car module in terms of like how these controllers are set in here? Like what you're needing is you need your controllers to be set in your mid-car module, and you need to ensure that like they're robust, they're able to be mounted, and they're able to have like that connectivity between modules, right? So that's like your top level constraint here that you want to stick towards, or definition that you want to stick towards. Now, when I see this problem, I see we're having issues with hole misalignment to a bracket, and we're having issues seeing this installation process. So I can see there's 3 controllers here. Now, when I think about this from like a manufacturability perspective, I'm like, okay, when we move forward to manufacturing and start scaling, there's going to be an operator that has to individually mount 3 controllers into the mid-car before this mid-car can move forward in the process. But when I think about my constraints, from a high level, the only thing we need is for the controllers to be in the mid-car. So we mentioned that there was a bulkhead that connects the rear car module and the mid-car module. Is there a way we can design out the part, essentially design out this bracket, and optimize how fast we can install this controller? So my immediate thought would be, since we're in prototyping stage and we're not in mass manufacturing, we can experiment with direct mounting all 3 controllers to the bulkhead and sliding the bulkhead in at one point. So an operator essentially has a lot more visibility into what he's into where he's fastening the controller, because the controller or the bulkhead's outside of the car, right? So you can mount your 3 controllers to a bulkhead and slide the bulkhead in and use that as a structural mount, like a structural component that's also able to mount controllers. So you can speed up your manufacturing process while designing out a part. If you just add the capability to the bulkhead to be able to mount controllers. I know that might be a little, of course you'd have to experiment with it, but that's something you could look at in this situation, since you are the design engineer and you own the design of these parts.
What's the first thing you brought up? First principle engineering?
First principles engineering. So
I feel like that kind of highlighted, or like your approach kind of highlighted that. And my initial answer, which is check tolerances, is like a direct solution to that problem.
Yeah.
But yours was like, because you can either fix the problem directly or you can innovate the system to eliminate the issue also.
Yeah, exactly. And that's like kind of the whole point of like taking a first principles engineering approach to problem solving. And I think that's like something that will be super helpful moving forward. And that kind of also touched on what we were talking about with like a systematic approach to problem solving. Like think of it as a system where design engineers will see a problem and try to solve that problem at the local level without thinking about like how their solutions could affect an overall system, which is a key thing that we kind of wanted to highlight in this podcast. And I'm glad we went through this example. Yeah, does that kind of make sense? Like that approach or that solution? Or are you like, nah, we should just widen the tolerances and have them install it individually?
Yeah, widen the tolerances and go home.
Or tighten the tolerances, I mean.
Yeah.
Yeah, but I guess that kind of, not to call you out or anything, Patrick, I'm not calling you out at all with this, but that highlights like the difference between a senior engineer's approach and like a junior engineer's approach to like solving a problem, right?
Yeah.
And I'm not saying like one's bad and one's good. I just think one comes with just a little bit more experience in the workforce. And yeah, how was that? Was that a
No, that's good. I wish I would have came up with that.
Nah, it's fine. But like stemming off of that, I guess we can go into like challenges for beginner engineers. Mm-hmm. So as engineers are like entering the workforce, we went through a specific example where we could see that a beginner engineer may experience more adversity and like problem solving versus someone with more experience. But as you've entered the workforce, what would you say like some big challenges you faced as a beginner engineer are? And it doesn't have to be like specific challenges. It could be things like confidence or
I think the biggest thing is like imposter syndrome, and like knowing like you worked hard and you're like supposed to be there. So like a lot of times you're just in rooms with just like really veteran or senior engineers, and you feel like, oh, I don't want to give my input because whatever input I have, they definitely know already. But a lot of times that's not the case. It's like they hired you and want new people to bring fresh eyes on things.
Yeah.
Because like how you said, it's like you're so ingrained into something you could forget the very simple things. So it's kind of like having the confidence to like speak your mind and know you have like the necessary skills and knowledge to contribute is probably one of the big things. I think internship experience really helped with that, because I think that kind of is what pushed me over. That was my first internship experience, just throwing me in and being like, okay, speak to all the engineers you need, all the technicians on the floor that you need. And that was like daunting, going up to like 40-year-old men with seeing this little kid there, like, what project are you doing?
Yeah, I agree. Yeah, you kind of hit the nail on the head there. I think a big challenge for me as a beginner engineer was not understanding cross-functional teams. So like, since I didn't know what all these other engineer teams were doing, it made me have no confidence in like what I was doing myself, because I didn't want to like propose solutions or contribute in meetings, because like I didn't know if what I was saying made no sense to another team, or it was like stupid to someone else in the room. And I think that's a tough thing to get over, especially at the beginning. And if you're in like siloed into a role that is so standardized that you don't get like that face to face or partner to partner communication, where it's like you're going through document communication, it's really hard to build upon that and get past that hurdle
Yeah.
as an engineer.
And I think
And
that
not only
like,
that, like when you start, you're definitely not a subject matter expert of what
yeah,
you're over. So that's like another thing that kind of hurts your confidence a little bit and makes you not want to take the leap and put your foot out there.
yeah. I think something I'm still struggling with or still trying to do, especially in this new role I'm about to start, is like your learning and growth is in your own hands. So like you need to put yourself out there. You need to ask questions. You need to, if something doesn't make sense, it's on you to go meet with other teams, understand what people are doing, how what you're doing relates to what other people are doing. And like, cause you're going to have coworkers and bosses that are super receptive to you. Like they want to teach you everything. Like, oh, this is the best employee ever. I want them to learn everything. I'm so proud of them. But you're also going to have people that are like, I just want to go home. I'm here just to make my money. I want to go home. Stop asking me questions.
Yeah,
So
definitely.
like, it's to have the confidence and like, it's in your own hands to learn. And if you want to learn, you're going to learn, even despite what anyone tells you or acts toward you at work or anything, you know? So I think it's
Yep.
like important not to get discouraged if you do have that coworker or boss that isn't so gung ho about teaching you or teaching you things and stuff.
Yeah, I agree completely. Now speaking on that, like we went through a couple challenges, but to like close out the final chapter of this podcast, how can a junior engineer or a new engineer in the workforce progress rapidly? And I feel like there's a few key things that a new engineer can focus on to better streamline their development. What are some things that you think could help in this situation? And I'll come from it at it from like my perspective of kind of like going through this process.
I'm gonna speak on kind of what I just said, like the attitude portion of it is like you got to have the attitude that you do want to progress and things like that, and reach out to people and learn as much as you can. I think that's like the most important thing, because there's going to be days or weeks or even like you don't get a lot of opportunity to learn other things, or you're super busy and swamped. It's just always, if you don't have anything to do, or if you're like learning about a system, like really want to learn it, like be doing something you want to learn more about. Hopefully you can be in that situation.
I agree. Like attitude is huge. If you're in a role and you're content, like you'll be there forever. Just staying content. That being said, like what you said, the attitude, seeking those uncomfortable situations. Like the more you become uncomfortable, the more you'll be comfortable moving forward. And yeah, I think a way to get there is to like really put yourself out there and approach problems using like the methodologies we talked about today. I feel like that's a good way to really take those first steps and focus on like becoming a subject matter expert. And to do that, you have to put yourself out there. You can't just take things as
Yeah.
they come.
And I think like knowing what you want out of your career is really important. So like, some people just don't want to be heavy into their career. They want to do it and then go home and do stuff they like, and that's fine. But other people also, they want to excel as fast as possible. So like I think like Christian, you're like a really good example of that side of excelling as fast as possible and things like that, because like your experience is insane and where you are now. And I feel like if you started at Toyota, you could very well like just still been there and
Yeah,
not like had all this crazy experience. And that's fine if that's like it's just important to like know what you want out of it. Like
exactly.
it's okay not to be a heavy career person. Of course, you still want to be good at your job and like what you do, but it's important to know what you want out of it. Because if you want to excel, you're going to excel. It's just
Yep.
choosing that you want to do that and putting in the work to learn everything and stuff like that, and learn as much as you can, as quickly as you can.
That's very true. Yep. Yeah. No, definitely. And I guess like to add some kind of closing remarks on kind of how you can accelerate as fast as possible. I know two things I really focused on when I started that kind of hit me in the face like with out of nowhere was understanding cross-functional team responsibilities as soon as possible. Like the faster you can understand what the entire business is doing as a whole, the quicker you'll be able to make like those super informed and super educated decisions as to what you're doing and have the confidence to be able to do it. And the last one, I think one of the biggest ones to me, to be honest, and something that I kind of struggled with at the beginning is adapting your solutions toward business objectives. So like as an engineer for a certain team, let's say you're in quality, let's say you're in manufacturing, let's say you're on design or MPI, it's easy to make your solutions tailored toward the success of your individual team. And what I mean by that is like a solution that works for your team and pushes your individual goal as an NPI engineer forward may not be something that makes the most sense for the company as a whole. So as an engineer, it's your duty to find what makes sense for the business that you're contributing to. And that's something that was kind of tough for me at the beginning. Like as a quality engineer, there's many situations where something that makes sense for me and makes sense for my role directly conflicts with like what the business needs. And I feel like it's on me as an engineer to find the best balance of that in the business. So the sooner you start adapting your solutions to like what the business needs, the faster you'll rise up in your career. And
Yeah.
you may be put in situations where like you're directly conflicting with what your direct supervisor may think, but it's all about like knowing in your core what you believe is the best for the business and sticking to your guns and having the confidence to do it. So, yeah.
I think one more thing is like that I struggled with also early on is just like, graduating and like finishing engineering is such like a big relief. It's easy to fall into like you get your first job and have the mentality of like, oh, I'm just happy to be here. Like the job market's so bad, I'm just happy to finally have work. And
Oh,
I
yeah.
think something you said, I don't even know if you said it or if like I don't know, but like trying to like think of everything you do day to day is like justifying you're justifying like your worth and your pay and stuff like that, kind of.
Oh, yeah, I did say this.
So like I
As
think
it,
that
yeah.
mentality is because I struggled with that a little bit. Like the first few weeks I was working, I was like, I'm just happy to be here. They don't expect anything out of me. But I think it's better to it kind of helps you propel forward of like, okay, how I spent this much time doing this week. How did this benefit the company? How
Yeah,
did this like justify my role? If someone came to me and was like, why are you here? I can answer them like confidently. Be like, I do this for the company. Like feel confident. Like if you left, like it'd be hard to replace you. Basically, like make yourself irreplaceable.
definitely. Yeah, I remember talking to you about this. Yeah, something I like try to go by is as an engineer, try to contribute to the company at least double what your salary is. That way, if you're ever in a situation where like layoffs are happening or management has to pick between their highest performing contributors and their lowest performing contributors, or like people are being considered for raises, they know, oh, Christian contributes at least double what we're paying him. So he should always be in a safe place, or we should always consider him for a promotional increase. And if you go by like that mentality every day, then you'll be set up for success. You'll be able to spearhead any issue that comes your way, and you'll always be motivated even in the face of like adversity. So yeah, that's a big one. Dang, I'm glad you remember that, because that's a big one for me too, that I try and stick to every day. Cool. Anything else you wanted to touch on in this?
I've said my piece.
Nice. All right. Sweet. So I hope everybody enjoyed this this podcast. I hope everybody was able to get a more in-depth understanding on like what it is to think like an engineer and steer towards those successful engineering thought processes and methodologies. And as a retrospective, just in case, like your goal as an engineer, you essentially want to be a subject matter expert and steer your business towards excellence. And to do that, you can use methodologies like first principles thinking and questioning your constraints, the black box approach, and thinking of problems as an overall system, and really challenge like your preconceived notions as to what you think is a successful solution for problems. So yeah, Patrick, if that's it, then everybody, thanks for tuning in, and we'll see y'all next week.